Assalamu alaikum. Welcome to lecture number 25 of Software Design and Architecture. I am your course instructor Fahad Anwar. So, students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So, students, if you remember what we discussed in our last lecture, we see interaction oriented software architecture, where we see interaction oriented software architecture decompose the system into three major components: data module, control module, and view representation module. And in this interaction oriented software architecture, we comprehensively discuss model view controller, and we also see some theoretical background about this model view controller architecture. And then we also discussed this model view controller architecture with some general example and with the help of some real world example as well. And then we also see a control flow, how control flow is actually being carried out in model view controller as well. And on the end of our last lecture, we see some benefits, limitations, and possible applicable domain areas where we can utilize this MVC architectural style. So students, this is a brief overview about our last lecture. So students, let's formally start our today's lecture discussion. So students, here is a brief overview of our today's lecture objective. So today we will discuss another category or type of architectural pattern, which is component based software architecture. And we also discussed different elements containing in any component model. And then we also see the architecture of component based development as well. And then we, at the end of this lecture, we see different possible applicable domain areas where we can utilize this component based development, and we also discuss some of their benefits and limitations as well. Students, here is a category of architectural styles which we have been studying from last few lectures. Just two architectural styles are remaining, and all of these patterns have been discussed in earlier lectures. In this lecture we will cover component based software architecture, and event based software architecture will be covered in next lecture as well. So let's formally start the discussion about component based software architecture. So students, what is component based software architecture? So students, what is a component? So basically component is, you can say, is a modular, portable, replaceable, and reusable set of well defined functionality which actually encapsulates its implementation and exporting it as a higher level interface as well. This terminology we call a component. So what the notion behind the component based architecture? Basically component based architecture focus on the decomposition of the design into individual function or logical components that represent well defined communication interfaces containing methods, events, and properties as well. This architecture also provides a higher level of abstraction and divides our problem into different subproblems, and each associated with component partition as well. We can also say that our primary objective of this component based architecture is to ensure the component reusability, and this component reusability is the most important aspect of this component based architecture. So students, a component, as I said earlier, can encapsulate functionality and behavior of a system element into a reusable and self deployable binary units. So there are many standard component frameworks are available like COM, Java Beans, EJB, Corba, .NET, web services, and grid services. All of these are different standard component frameworks are currently being provided by the industry. and these technologies are widely used in local desktop based graphical user interface applications designs such as graphic Java Beans components, MS ActiveX components, and COM components, which can be reused by simple drag and drop operations as well. So design can make use of existing reusable component, which we also call the codes component, which are actually an acronym for commercial off the shelf components, or ones which have been developed in the in-house, and they may produce some reusable component for future reuse as well. So this reusability actually overall, this reusability approach actually increases the overall system reliability, since the reliability of each individual component enhances the reliability of the whole system via reuse, because reusability is the main aspect or concern of this component based architecture. And we also discuss this how reusability also supports the reliability in component based architecture. We will discover about the tradition between the reusability, how reusability supports towards the reliability in coming slide. So let's start from the component. So student, what is a component? So basically, a component, we can say that, is a modular, portable, replaceable, or reusable set of well-defined functionality which actually encapsulates its implementation and exporting it as a higher level interface. It's a most basic notion of component. So a component is a software object. Basically, a component is a software object which actually intends to interact with other components, encapsulating certain functionalities or a set of functionalities as well. So a component is a deployable software package that provides services to its clients. You can, in easy terms, can say that a component is actually a deployable software package which can provide services to its clients. So it may also itself require services from other component as well. So component is a higher level of abstract concept than classes as well. A component may consist of many related classes stored and deployed in same binary assembly as well. So my student, there will be question in your mind, why we use this component, why we need to introduce this component in our life. So basically students, this component oriented architecture actually provides us the reusability, productivity, composability, adaptability, scalability. These different non-functional requirements or these different characteristics are actually being provided by this component oriented design, and development is very useful, especially in enterprise frameworks. That's why this component oriented architecture is currently being progressively demanding in the market, because a component is developed for reusability, so it must have a clear functionality and be self-contained. So components must be designed and developed for easy reuse, because reuse is the most basic aspect of this component oriented software architecture. So components should therefore be very reliable as well, because the reusability approach also provides the basic support towards the reliability of components. So any interface of a component actually plays a vital role to contract between its implementation and clients. So hence this approach is sometimes also called a contract oriented software architecture as well. So this contract oriented software architecture is also another name for component based software architecture. So the first step in our component based development is to design and to identify the first cut component, which actually specify all necessary connections among these components, and the connections are conducted via the interfaces components. So you will get better idea about how actually the component look like in the next slides, where we will discuss the different component interfaces as well. So students, components can be made of different aspects, as components can be made of source code. Like source code can be contain classes like one or more possibly related classes. Components can also be made of executable code, like object executable code can be object code or a virtual object code as well. So components can also be summarizes of other files like images, text, indices. So these are the three different major aspects from where a components can be made of. So here are the component interfaces, how actually component look like. There are basically two interfaces for a component. First interface we call a require interface, and the second is a provide interface. So require and provide actually are two interfaces for any component. So this diagram actually shows how actually a component look likes and what are the different interfaces actually any component have. So there are two components provided by any component is our provide interface and require interface. And require interface are actually represented by this open angle, and the provide interface is actually represented by this closed circle loop. So what are the provide first discuss the require interface. So students, what are basically the require interface actually defines the services that specify what services must be made available to be component to execute as a specified. This require interface does not compromise the independence or deployability of a component, because the reason is require interface does not define how the services should be provided. So you can conclude about this require interface is it actually defines services that the component use from the environment. So these are provided by the require interface, and these require interfaces are actually represented by this open bracket as well. So what are the provide interface? So provide interface actually provides the services that are provided by the component to other components. This provide interface essentially is the component API, or the component application program interface. API stands for application program application program interface. So it actually defines the method that can be called by a user of the component as well. So this provide interface actually define the services that are provided by the component to other components as well. And this provide interface is actually represented by this closed circular loop as well. So this is a basic architecture of component interface. So let's discuss the a model of a data collector component. So here are the require interface and the provide interface as well. So here the require interface, you can see that the sensor management and the sensor data. So students, what they are actually being represented. So if you notice actually what are the require interfaces. So basically require interfaces define the services that specifies what services must be made available for the component to execute as specified. So if you look in this diagram about a model of a data collector component, as shown in this figure, you can see that this model of a component that has been designed to collect and collate information from any array of sensors. It runs autonomously to collect data over a period of time. On request, provides collected data to calling component, and the provide interface include methods to add, remove, start, stop, and test sensors as well. The report method returns the sensor data that has been collected, and the list all method provides information about the attached sensors. Although I have not shown in this here, because these methods have associated parameters specifying sensors, identifiers, locations, and so on. So the required interface is used to connect component to the sensors, and it assumes that sensors have a data interface, access through sensor data, and a management interface accessed through sensor management. So this interface has been designed to connect to different type of sensors. So it does not include specific sensors operations such as test, provide reading, etc. Instead, Commands used by specific type of sensors are embedding in a string, which is basically a parameter to the operations in the required interface. So adapter, there are different adapters are available we can utilize for this task. So basically this is an example of a model for a data collector component, which actually has been designed to collect and collate information from any array of sensors. It runs autonomously to collect data over a period of time on request, provide collected data to a calling component as well. So these are the different require interface services and provide interface services are provided by this data collector component. So this is an example for us from an environment which actually autonomously being used to collect data over a period of time, and on request provides collected data to a calling component. And this data collector component actually shows they require interfaces and provide interfaces. The required interfaces include the sensor management and the sensor data. So this required interface is used to connect the component to sensors. So it assumes that sensors have a data interface which access through sensor data, and a management interface uh, associated through sensor management. So this interface has been designed to connect to different type of sensor, so it does not include specific sensor information. And on the other hand, provide interfaces is actually being shown. This provide interface includes method like to add, remove, start, stop, and test sensors, and the report method returns to sensor data that has been collected. So student, this is a real world example for data collector component in a sensory environment where data has been collected from the environment. So these two services are provided by the required interface. These are the two required interfaces include the sensor management and the sensor data, which actually gets the data from the environment. And what kind of services are actually being provided to the user are provided through this provide interface, like user can add sensor, like remove sensor, like start sensor. So the required interface actually gets the data from the environment, and this provide interface actually provides services to its users. What kind of services in this data collector component is currently being provided to users, like add sensor, remove sensor, start sensor, and up to report initialize? All of these services are actually being provided by to the user in this provide interface, and the require interface is actually uh, specifies what services must be made available to the component to execute as specified. And this sensor data and sensor management is actually, this data is actually being continuously being receiving from the environment. So this is the discussion about real world example of any component which is a data collector component worked on a sensor oriented environment. So there are some basic elements of a component model. So what are the basic elements included in a component model? So students, if you see in this diagram, there are different elements of a component model contain. There are three models actually. Any component model contains the interface, usage information, and the deployment and use. And what are the interface, which is the first element of this component model? Basically this interface, in this interface components are defined by specifying their interfaces. Like component model specifies how the interfaces should be defined and the elements as well, such as we can say that operation names, different parameters, exceptions, which should be included in this interface definition as well. And the next component and the next element of this component model is usage information. Like in order to components to be distributed and accessed remotely, they must need to have a unique name or handle associated with them. So this has to be globally unique. So this is the component of usage information, and there which contains some metadata access as well, some naming conventions which should be globally unique as well, and different customizations as well. And the third element of component model is uh, development and use, which this development and use element is actually responsible for to include a specification of how components should be packaged for deployment as independent executable entities, and the documentation and maintenance support is also provided in this deployment and use element. So this is a three basic elements which actually forms a component model: the interface, usage information, and the deployment and usage. So students, now let's discuss some possible applicable domain areas of how where we can utilize this component based architecture. So students, this component based architecture is commonly utilized where interface contracts between subsystems are more clear, and where the communication between different interfaces or different subsystems are more clear and well understood. And we can also use this type of architecture where we require loose coupling between the components, and where many reusable components are available. And so as I discussed earlier, reusability is the main concern of this component based development. So this reusability is also supports towards the reliability. And we can utilize this component based architecture where actually we require a loose coupling between the components, and we also require some reusability of components as well. So what is the coupling and cohesion? So student, these are the two terminologies in constantly being utilized in design and architecture course. And coupling and cohesion we already discussed in our earliest lecture, if you remember. So if you remember, a good program should have a minimized coupling and high cohesion. So basically, cohesion actually refers to the interdependencies between modules, while cohesion describes how related the functions within a single module. So one is interdependency and the other is interdependency. So a good program should have minimized coupling and high cohesion. So this type of component based architecture is suitable for class library system organizations like .NET class library, like Java APIs, which are built in component architecture as well. So these are the different possible areas where we can utilize this component based architecture. So here we discuss three broader categories where we can utilize this. The number one was the environment where the interface contracts between subsystems are more clear, and for those applications which actually requires a loose coupling between the components, and where reusable components are available as well. And then the last one is the this type of architecture is mostly suitable for class library system organizations like .NET class library, like Java application program interfaces are built-in component interfaces. So these are the situations where we can utilize component based architecture. So here are the some benefits of this component based architecture as well. So like reusability is provided by this component based architecture, which also supports reliability and availability as well. Like maintenance and evolution support is also being provided by this component oriented architecture. It also supports the independence and flexibility components between components as well. And independency of development of components by different groups are parallel. It also supports productivity, so that the current and future software can be developed very fastly, because the reusability is the basic concern of this component oriented architecture. Once any architecture provides a reusability, so reliability is also increases, and the productivity will also be fast, because the reason is we already being used commercial of the shelf components which are already is available in the market as well. So many object oriented design tools can be used for component based software development as well. So student, these are the different benefits of component oriented architecture. So there are a lot of other benefits of this component oriented architecture as well, like independent encapsulation, not extent specific replaceability is also provided by this component oriented architecture. So not these 5 6 are not only these 5 6 are the benefits of this component oriented architecture. There are a lot of other advantages or benefits are also available, like ease of deployment, like reduced cost, like ease of development, like modifications of technical complexity as well, like independency of modules is also being provided. So these are the different perspectives and concerns of component oriented architecture, and reusability is the main pillar of this component oriented architecture. So where we have some benefits, there are some also some limitations as well of the component oriented development. Like it can be difficult to find suitable available components to reuse. All of the components are not already always available as well. So adaptation of component is also a necessary issue as well. Like few component oriented dedicated design tools are available. So for component oriented development, there are not too much tools are available. So this is also another limitation of component oriented development. So here are current component technologies available in the market. So student, these are the different component technologies like common object request broker architecture, which is an acronym for CORBA, and enterprise Java Beans or Java API, which is actually acronym for EJB, and component object model. So these are the different uh, current component technology which are actually available in the market with different perspective as well. So you can self study about this slide. You can get clear idea about how the current component technologies are actually being provided in the market, and where we are actually stand in the environment of component oriented architecture as well. So students, let's we conclude our today's talk about in this conclusion slide. So student, till here we comprehensively discuss the component oriented or component based software development as well. So as we discussed a lot of time what is a component, so students, I can conclude my talk over here is that basically a component can have three different views. Like these three different views are number one, object oriented view, conventional view, and process related view. In object oriented view, a component is viewed as a set of one or more cooperating classes, and in the conventional view, a component is viewed as a functional element or a module of a program that integrates the processing logic and its internal data structure as well. And the third view of component is process related view. So in this process related view, instead of creating each component from scratch, the system is actually built from existing components maintained in a library. This here comes a reusability as well. So component has a different views in object oriented paradigms, conventional views, or in conventional paradigms, or process related paradigms as well. So any component have different views in object oriented, conventional programming, or process related as well. So students, here are the different component based development is best implemented using modern software technologies are available. These are the different modern software tools and technologies are available which are actually being utilized for the component oriented software development, like COM, Java, EJB, Corba, ActiveX. These are the different tools available for or different software technologies or environment which are actually currently being provided by the industry to deal with the component based software development or architecture. So students, still here our discussion about component based or component oriented software architecture comes to an end. So students, lecture number 25 is ended here.